Welcome back to Start E-Learning. In this video we will discuss about all the important concepts in the matrices, and now we will discuss about what is matrix. So matrix is the arrangement of numbers in the form of rows and columns to form the rectangular array. Okay, so this is what the matrix is. See here, so these are the rows. This is row 1, this is row 2, and this is row 3. And when we come to the columns, so this is column 1, this is column 2, and this is column 3. So what is matrix? So matrix is the rectangular arrangement of the numbers to form the rectangular array. Okay, so that's what the matrix is. When we come to the square matrix is nothing but whenever we have number of rows equals to number of columns. So in that case, that matrix is said to be square matrix. And then we'll discuss about the rectangular matrix. When we so rectangular matrix is nothing but when number of rows is not equals to number of columns, in the sense, so that case the that particular matrix is said to be rectangular matrix. Now we will see one example. So see here, A, B, C, D, E, F. So this is what the rectangular matrix is. So see here, every matrix is represented here as row by column. Okay, so this is in basic will what? So in basic we will call this as a multiplication symbol. But when we come to the matrices case, so it will be termed as by. Okay, so row by column. So here we have 2 rows and we have 3 columns. That's why it is represented as 2 by 3. So this is what 2 by 3 matrix, that is number of rows and number of columns are not equal. And also A, B, C, D, E, F. So here also this is 3 by 2 matrix, right? So here 3 rows and 2 columns. So this is also a rectangular matrix. Okay, so that's what the rectangular matrix is. And then while we come to the row matrix, in row matrix only one row is present. So at that case, that particular matrix is termed as row matrix. Okay, so this is what the row matrix is. Here only one row is there and we have 3 columns. Okay, so this is what the row matrix is. And when we come to the column matrix only it's having 1 column. Okay, see here we have 3 rows and we have 1 column. So this is what the column matrix is. While we come to the null matrix, so null matrix is nothing but it doesn't have any elements. So it may consist of 0. See here, null matrix, so it may contain 0 or it may contain 0, 0, 0, 0, likewise. So this particular matrix is said to be a null matrix. Okay, so null matrix is also termed as the 0 matrix. Now we'll discuss about the principal diagonal. Okay, so when we come to the principal diagonal, the row whenever we have I equals to j, so that particular elements are said to be the principal diagonal elements. Okay, see here, A, E and I. So these 3 elements are said to be principal diagonal elements. Okay, so that's what the principal diagonal is. And then when we come to the trace of the matrix, so trace of the matrix is nothing but sum of the principal diagonal elements. Okay, sum of the principal diagonal elements. So let me take the same example. So when we come to the trace of these particular matrix, in the sense, let's assume this matrix as A. So trace of A in the sense A plus E plus I, A plus E plus I. So this is what the trace of this particular matrix. We'll take one example. 1, 2, 3, 4. So trace of this particular matrix is 1 plus 4. Okay, 1 plus 4, that is 5. So this is what the trace of the matrix is. And then we'll discuss about the diagonal matrix. So when we come to the diagonal matrix, all the elements, that is, whenever I equals to j, it consists of elements. Otherwise, if I is greater than j or I is less than j, at that case all the elements are 0, in the sense that particular matrix is said to be diagonal matrix. We'll see one example, then you will come to know. So 1 0 0 0 2 0 0 0 3. Okay, see here, whenever we have I, so I equals to j, so at that case we have elements. When I is greater than j, okay, so when I is greater than j, we have zeros. When I is less than j, we have zeros. Okay, so at that case that particular matrix is said to be diagonal matrix. Okay, so this matrix can also be represented as 1 2 3. So likewise, so we can also represent this particular diagonal matrix as like this. So that's what the diagonal matrix is. And then while coming to the scalar matrix, so scalar matrix is nothing but so unit matrix which is multiplied by the any one scalar. Like let's assume 3 as a scalar. So that particular matrix, unit matrix. So this matrix is multiplied by scalar, that is assume that the scalar as a 3. So when we multiply this with the 3 0 0 0 3 0 0 0 3, likewise. So this is what this scalar matrix is. And then while coming to unit matrix, so unit matrix is nothing but whenever we have I equals to j, at that case we have 1 as a element. So in the remaining all the cases, that is whenever I is greater than j and I is less than j, at that case we have 0. So that's what the unit matrix is. And then we'll come to the triangular matrix. So first we will discuss about the upper triangular matrix. Okay, so upper triangular matrix in the sense, I'll write one example, then you will come to know. 1 2 3, next 0 4 5 0 0, and then 6. So this is what upper triangular matrix. Okay, so this is how upper triangular matrix will look like. And then when we talk about the lower triangular matrix, so these particular 3 elements are replaced by zeros. Okay, so this is what the lower triangular matrix. Okay, so whenever we have the matrix like this, so it will be treated as upper triangular matrix, and when we have the matrix like this in the sense, so that particular matrix is said to be lower triangular matrix. While coming to the triangular matrix, all the diagonal elements are zeros, remaining it consists of elements. Okay, so we'll discuss with example. So see here, whenever we have the diagonal, all the diagonal elements should be 0. Okay, 0 1 2, next 3 0 5 7 0 0, likewise. So this particular matrix is said to be the triangular matrix. That is, all the diagonal elements are 0 and the remaining all elements are not null. Okay, so that's what the upper triangular, lower triangular and the triangular matrices are. And then we'll discuss about the transpose of a matrix. So transpose of a matrix is nothing but transforming the rows into columns and columns into the rows. Okay, so let's take this matrix itself. So assume that this is a matrix. So transpose of the matrix can be represented as like this. So I'll write the transpose of this. So A transpose equals to A. So what I said, transforming rows into columns and columns into rows. So see here, A, B, C. So here it is a row. So this row is converted into column, B, C. And then D, E, F, it is converted into other column. So D, E, F. And then G, H, I, it is converted into column, G, H, I, like this. So this is what the transpose of the matrix. Okay, and then we'll discuss about the symmetric matrix. So what is symmetric matrix? So whenever we perform the transpose operation of that particular matrix, so when A transpose equals to A, so at that situation, that particular matrix is said to be symmetric matrix. So this is what the example is. So assume that this is as A. When we transpose this matrix, A transpose, so rows becomes columns, columns becomes rows, right? So 1, -1, next -1, 2, likewise. So what you observed, A equals to A transpose. So this is what the symmetric matrices are. So whenever we transpose the matrix, that will result the same matrix. At that case, that matrix is said to be symmetric matrix. And then when we come to the skew symmetric matrix, so whenever we transpose that particular matrix, that will result in minus A. So minus of the original matrix. At that case, the matrix is said to be skew symmetric matrix. Okay, we'll discuss with example. So this is what the example is. So when I try to transpose this particular matrix, A transpose equals to so 0, 5, -5, 0, like this. So see here, what is the difference when we perform minus A? When we multiply these particular matrix with minus, so that matrix is transformed as 0, -5, minus into minus plus 5 and then 0. So what you observed, see here. So A transpose is equals to minus A. So this is what the skew symmetric matrix is. Now we'll discuss about the real matrix. So what is real matrix? Here, a real matrix consists of all the real numbers. Okay, so either if in a matrix at least one element is the real number, in the sense that particular matrix is said to be a real matrix. Okay, so I'll write one example. So 1, √2 and 3 -4. So here √2 is the real number. So that's why this particular matrix is said to be a real matrix. And then we'll discuss about this complex matrix. Complex matrix is nothing but it consists of the complex number. So first we'll discuss about what are the complex numbers. So complex numbers are nothing but which is of the form A plus IB. Okay. So whenever the element is of the form A plus IB, So that particular term is termed as complex. So next. So while discussing about this complex matrix, it consists of complex numbers. Okay, so that is 1 plus 2i, 3, 4, 2 minus 3i. So this particular matrix is said to be a complex matrix. Okay, now so we have discussed about this complex matrix, and then we come to the Hermitian matrix. So this is also termed as conjugate transpose. Okay, so conjugate transpose. So we'll discuss with one example. 1i minus i1. The matrix is said to be Hermitian matrix whenever it satisfies the condition A equals to A transpose whole bar. Okay, so the bar is nothing but conjugate of that particular element. Okay, so A plus IB. So if something x equals to A plus IB, in the sense x bar is termed as A minus IB. Okay, likewise. So we'll discuss with this. Assume that this matrix has A. Now we'll perform the transpose operation. Okay, so A transpose equals to 1 I minus I and 1. What I told you, we have to perform the conjugate operation, right? So see here, when we perform this conjugate operation, this particular A plus IB is converted into A minus IB. So same condition applied to this matrix. So A transpose whole bar equals to 1. This minus is converted into positive I, and then here positive I is converted into negative, and then this one remains same. So what you people are observed here, see here, A is equals to A transpose whole bar. So this, whenever the matrices satisfies this particular condition, at that case the matrix is said to be a Hermitian matrix, or it is also called as conjugate transpose. So please like the video and subscribe to our channel for more updates, and press the bell icon.